Hello everyone, welcome back. I am glad to officially start the conference panels. And our first talk is about unlocking recycling potential with Clariant specialized solutions. And our speakers are Seval Schnitzel. She's the Global Business Development Manager, Business Unit Catalysts at Clariant, and Maria Ruby Quintin, Product and Application Development APAC, also at Clariant. Seval focuses on strategical chemical recycling projects and has over 15 years of experience at Clariant. She has a strong foundation in catalyst, research and development, testing and management, including roles as R&D manager and head of the R&D testing lab. Maria is the head of product and application development for purification in the adsorbents business unit at Clariant. She's based in Jakarta in Indonesia and serves as a product manager and innovation leader in the region. She has 15 years of experience in the adsorbents business and has developed deep expertise in product applications and innovative solutions for customer challenges. Please welcome them on stage.
Oh, thank you. You can sit. You take a seat. Yeah. Hi, everyone. I think the mic is on now. Yeah, thank you. Good morning, everyone. It's nice to see you all today. I'm very excited to have this first presentation today with my colleague Marla, because we are talking about a very exciting topic here, plastic recycling. So before we start with the more interesting part of his presentation, I want to say a few words about our company, what Clariant is doing for those of you who do not know Clariant. So I've been working since 17 years now at Clariant, so I have literally seen this company growing from a family-owned company called Südchemie to a worldwide leading specialty chemical company, which is globally acting in the world. We have more than 10,000 employees in the company. So it was an exciting time to follow this growth of a company from family-owned to a very large international company called Clariant now. It's a Swiss-based company. So we are focused on three core business, I would say. We are reporting in three different business units. One is what we call care chemicals. In this, we focus on household care, on home care products, on health care products. That's the focus of this business unit. In the next one, the catalyst, that's the business unit where I'm working since 17 years now. Here, in a nutshell, I can say we focus on supporting our customers in improving efficiency of the process, improving performance of the process, also sustainability in terms of CO2 reduction, for example. That's our main interest, I would say. And in the last core business, the additive and adsorbents business unit, where my colleague Marla is working, here we are worldwide leading providers for minerals. And I would mention especially the application of purification, because that's the reason why we are here today. We have a cooperation across our company, cross business units between adsorbents and catalysts. Because in this field, in the application of feedstock purification, that's where we have our expertise. That's where we come from. That's what we are doing successfully commercially since more than 100 or 115 years, purifying feedstocks, but challenging feedstocks. Feedstocks which are waste-based. For example, edible oils purification or used cooking oil, UCO purification to support the sustainable aviation fuel production. And on the catalyst side, there is one example I want to mention here to highlight. That's the ODH. It stands for oxidative dehydrogenation of ethane to ethylene. So that's an alternative process to produce ethylene. And I want to highlight this example because at Clariant, we have different operating models. We are an independent catalyst supplier, an independent materials supplier, But when it comes to cases where the market needs full scope technology, complete solutions, then we have very strong partners on our side to be able to provide the process and the materials. And that's an example for that. ODH, in this case, we were able with our partner, in this case it's Linde Engineering, to come up to the market with an innovative solution, providing a new catalyst type with the process, producing ethylene on an alternative way, which has a better performance in terms of selectivity and activity, but most importantly, which has a very, very improved impact, so CO2 emissions codes. Yeah. So an example for our operating models that we are independent, but we have also successful cooperations with engineering partners. And then brings me slowly to the more interesting part of this presentation, because that's also what we are doing in plastic recycling. So we have there the products, but we also work with engineering partners so that we are capable to offer the complete technology. And in the case of plastic recycling, we are working together with Technip Energies. They have patented solutions for processes, and together with our materials, we are capable to offer the complete solutions. So that brings me to the interesting part of his talk, plastic recycling. And my colleague Marla will take us through this part. Hand over. Thank you.
Thank you everyone for having us here. So we are going to present you our solution in plastic recycling. Let's say the main function for adsorbent, Clariant adsorbent, we going to introduce you an HD Max catalyst. It's going to enabling physical and chemical recycling. As an overview, what I'm going to share with you on the application, how we are contributing in the dissolution process, and also in the stream of pyrolysis process. It will be, we have Clariant pyrolyze for catalyst, and then we have Clariant Protex that able also synchronize with HD Max to upgrading your oil. Starting with the dissolution process, this is very straightforward. I mean, for some who have physical recycling on the plastic to able to use again as a plastic, our solution able to give you, let's say, removal of the hazardous contaminant and then colorant pigments on the plastic, recycle odor, heavy metals. It will enable you to recreate the food grade plastic, recycled plastic. And because our product has known and has applied the application on purification in edible oils so long, so it's already certified safe for the plastic to be used as a food grade. And then continue with the pyrolysis process stream. So here, so our active materials can be also used during pyrolysis of a plastic waste to improve the process. It's able to reduce the temperature on the process itself, and then tailoring product distribution, mitigating impurities in situ, and what we want to say that Clariant will provide a broad range of commercial materials to suit your process need. So if you look at on the right side graph, so it is a lab result that we see comparing other materials, how our product and our adsorbent able to give you lower temperature to have the product distribution that what you aiming. So, and continue on the roles of our adsorbent. We can purify and stabilize your pyrolysis oil to have, let's say, safe in transportation, and then enabling longer life cycle in the storage to make it more stabilized will optimize your total cost of ownership because our adsorbent able to be regenerated. So if you can see in the right side here that for the virgin, let's say virgin adsorbent, first use, we able to uptake this is chlorine, or organic chlorine impurities.
Laser.
I can use the laser saw. Yeah, so this is the first use, and up to 10 regeneration, we can still have the, let's say the capacity is still there. So this will going to improve your total cost of ownership. And we can, let's say also in operation, we can have better stabilization and then corrosion prevention because this is mainly organic chlorine, and then you will have regenerated adsorbent as your additive process. So for this, we also, as Eva mentioned, that we are collaborating with engineering company. So later we will have that. To move further for the process, Eva will explain it to you.
Yeah. So if I just go back for 1 second on the last slide, she was presenting here a purification method which is applicable, I would say, for standard-wise 10, 20 kTA capacity plants and for normal quality pyrolysis, I would say. But when it comes to higher quantity, I mean, in Europe, I'm not quite aware about the legislations here in Singapore, but in Europe, in 2030, we have to implement 30% recycling quote, 2050, 50%. I mean, with 10T and 20 kTA pyrolysis, we will not achieve that. Yeah? So when it comes to higher amount of being processed to the steam cracker, when you need a few hundreds kTA pyrolysis being upgraded, as in this case, we have developed a technology where we combine the first step of purification with adsorbents, as Marla was presenting, combined with the hydrotreatment in the second step. This has the advantage that you can, in the first step, decontaminate the pyrolysis, and in the second step, you remove the remaining contaminants, but you also saturate the olefins, the dyes, and at some extent, if it's wished, also the aromatics, for example. Yeah? But I would say that's something we are doing since years. We're moving impurities from feedstocks. Okay, that's not rocket science. So what is exactly behind? So the challenge here is not really to remove impurities from hydrocarbon feeds. The real challenge behind is that you are handling waste. And as such, is not defined. So you don't have a specifications of feedstock coming in. So you have to establish a process which is robust, which is stable against this fluctuation. As you are processing waste, plastic waste, depending on the region the waste is coming from, depending on the sorting facility, depending even on the season. We have different waste in winter than in summer. So you will have a fluctuation in the impurity profile in your feedstock. And that's the real challenge here. That's what you have to address to be capable to handle the feedstock independently on this fluctuation with your process. And that's where we have here, I would say, a differentiation is that here, with this process, we are capable to address exactly this flexibility, because here we are working under continuous batch mode that brings us the advantage that we can choose the material independency of the incoming quality of feedstock. We can choose, we can even think about combining different adsorbents depending on what is coming in. Yeah? And we can minimize the dosage of adsorbents, yeah? Because we analyze the incoming quality, then we know from our expertise and our benchmarking which adsorbents we use the best, if we have to combine, and at which lowest dosing rates we can work. So exactly here, we are addressing this flexibility, this fluctuation in the pyrolysis or incoming quality. That's one of the most important features of this technology, I would say. Yeah? Then coming to the catalyst side, we are doing exactly the same, but we have developed a multi-layer design where we can address, depending on the incoming quality, the different specifications with different targets. And normally, in general words, I can say we have, we have like a mechanical filter, and then we have, we will have a layer where we already remove some metals. We have a very selective catalyst removing selectively silicon and phosphor, for example. And at the end, the main part will be the main hydrogenation, where you remove then the rest of the contaminants and the and saturates at the extent wished by the customers, which is also really changing heavily from one customer to the next one, depending on the sim cracker, etc. Yeah? So at the end, I would say, in a nutshell, so this technology was demonstrated at different scales. We have demonstrated this technology even in our lab at pilot scale, for example. But most importantly, this technology was technically qualified at customers. Yeah? And one of these customers is a very large petrochemical producer. To resume, what we are offering in this field, as Marla was saying, so we have solutions for the dissolution field, we have solutions for the pyrolysis itself, then for the upgrading of the pyrolysis oil, for the upgrading of the main product coming out of the pyrolysis. And depending on the purity, we can apply either purification only or purification followed by hydrogenation. Yeah. So, and with this, I will hand over back to Marla, and she will explain you how we normally work with our partners, with our customers, so how we could potentially work together if we are interested in our technologies. Yeah? Marla? Yes. Is the pointer? I don't know.
Yeah. So how we work usually that because, let's say, pyrolysis oil is kind of different and need to be specifically addressed, right? So usually we will have pre-evaluation. We discuss on existing process and existing condition quality of let's say of the black bio itself, and then we do the screening and optimization. What type of adsorbent that we need to use, any conjunction, any configuration or process that you need to have. There, we further have economic evaluation compared to existing process, and then continue with pilot testing. So the pilot testing can be in our lab or in our customer facility. That be also possible. Yep. And the last time is we can have a production line, I say. Yeah. This will be continuous collaboration between us and of course the industrial practices, and then it will be also exchange experience, exchange of data to have the optimized solution for the process itself. And overall, so let's say that we've explained from the beginning that it is further and further we will face more difficult feedstock on the pie oil. There's a lot of fluctuation on the quality of the oil, the type of polymer itself. So it needs to have specific addressing. So we as a adsorbent have been in the industry for more than 100 years. We have a lot of commercial product to deal with the challenging feedstock, and we will have the comparability of adsorbent and catalyst from one supplier if we have this let's say holistic solution for your process. It is flexible to be adjusted, whether it's dosage, whether it's a type of a solvent, and then you're going to have a milder condition during purification, for example, like probably for milder feedstock, you don't need to go to hydrogenation and have a lower temperatures. At the end, it will minimize your total cost of ownership. So if you want to know more and discuss with us, please contact us. And then you can visit also our website. And yeah, thank you for having us. Thank you.
Yes, we have plenty of time for questions. Thank you very much.
No,
Yeah, you should say. So, okay, yes, back. Great.
So I open the floor for questions now. If you have a question, please raise your hand. First question, if we could get the mic over there to the fourth row, please. Can you keep your hand up? Thank you.
Thank you. Christelle Kapurian. Just interested in your process. How sensitive is it to multiple different types of polymer? Like, do you have to sort out the polymer before it's able to enter the process, or does the process itself able to account for the different melt points, etc., of the polymer when it's producing the pyrolysis of it?
Okay, so first of all, as I said, now we are delivering the products, catalysts, and materials. So concerning the process, we have our partners on our side. In this case, that would be Technique. But are you asking about which type of polymers we are processing? Like, we are working mostly with mixed plastic waste.
Yeah, so mixed plastics. In the case of mixed plastics, you'll be receiving PET, HDPE, LDPE.
It is.
Yeah, rock PVC, correct. And so what my question is do you have to sort those out prior to the pyrolysis process, or are you waiting for or is your system capable of being able to deal with all those polymers you've just mentioned actually in the process? Or are certain polymers a contaminant, which is the case of some?
So I would say to some extent, yes, we can really process to some extent PVC, it's other type of polymers inside, but it's really depending on the process that you use for the pyrolysis itself. So what Malia has shown is that we offer products to in situ already reduce the type of the impurity profiles, but what you are asking is really coming from a process itself, no? From like plastic energy, etc. So,
Understood.
to some extent, yes.
Thank you.
Welcome.
Thank you. Any other questions from the audience?
Hi, I'm Luo. I'm from Vista. So thank you for your very impressive talk. So my question is, do you have interest or any other efforts in your company for closed loop recycling? For example, to break down PE, PP, and PE back to monomer, and then to produce the original monomer, to close the loop.
I'm not sure.
Maybe can you move your microphone a bit closer to your mouth? We struggle to hear you.
I only get the point to closing the loop, but what was the beginning of the question?
If you just put it closer, we'll be able to hear you better.
For the close loop recycling.
Yeah.
Yeah, closed loop, for example, break down PE, PP, and PET back to monomer. So, do you have any effort of such work in your company?
Can we get the presentation back and running? Thank you.
Okay. So actually, that's exactly the target of this. That's exactly what we are doing. But if I get the presentation back, perfect. Let's go to the interesting part here. So that's what you are asking for is this one, yeah? And here. So here, we are processing pyrolysis oil, which is coming from a plastic, and target is to have a steam cracker compatible quality at the end, which you achieve by combining both the adsorption and the hydrogenation. You have a product, a hydrocarbon feedstock at the end, which is steam cracker compatible. So you go back to the steam cracker, produce ethylene, propylene, PE, PP, and close the loop. That's exactly what we are doing here.
Thank you.
Yeah, welcome. And what I forgot to mention, maybe I can make an addition here. Also, a very important differentiation is here. Why it's moving here? So here, in this step, we are not working under hydrogenating conditions. This step is really working under ambient temperature and ambient pressures. So, and it's different to other technologies available in the market, where they use a sequential catalyst. In this case, it's happening. In this case, they are working under high pressure and high temperature, which we do not have here. So that was what she was highlighting about minimizing total cost of ownership here. Yeah. So here, really under room conditions, if you want, pre-treating the oil, and then you go to the step of hydrotreatment of the oil, and at the end you have the oil really high quality with high capacity, which is steam cracker compatible. And then you close the loop again. Did it answer your question?
Thank you. Any more questions from the audience? Okay, so I have a follow-up question actually from Chris. First question about the feedstock. Do you have data on how efficient the process is depending on whether or not you sort the waste in the beginning of the process or not? And if you have very contaminated mixed waste, of course, in pyrolysis and chemical recycling, usually if you put something dirty in, what comes out is also relatively dirty. So just curious if you have data on what works best, how much does it have to be sorted, how mixed can it really be?
Very good question. And you see here, that's exactly related to what you are asking for. So regarding the process, that's not where we are coming from, but we have a very extensive knowledge now because we are working this field since 2020, so 4 years already, and we have made a lot of experiments with, I think we have seen up all, but pretty much a lot of different pie oil qualities. So we really have seen high quality pie oil up to something that you cannot really call oil anymore. So, and from that, we know which impurities under which conditions, because you cannot look only at the single impurities. It comes with a matrix. The first step, for example, here, you will not absorb only the chlorine in the first step. If you have a lot of nitrogenate oxygenates, you will have some losses there. So we have an extensive knowledge now about which type of products we can take here and here, depending on the incoming quality. That's exactly why we have now our expertise.
Maybe I can add some. So in the terms of let's say adsorbent itself, so it's purified, right? So it's protect, it solve your problem to remove impurities. Heavy metal usually we're not focusing on what type of plastic, for example. We are more to know what impurities that there in the feedstock and then what need to remove. So that's all we need. That's all information we know. Then we will adjust what type of absorbent we should apply, what condition that we should go through on the process.
And that's it. Thank you. We have time for one more question from the audience, if everyone is feeling brave. Okay, then I will feel brave and ask one more question. Something else that we always want to ask for any technology providers for chemical recycling and pyrolysis in particular is, how is the market responding? Of course, Switzerland based, Europe is slowly considering whether or not in the EU if chemical recycling will count towards recycled content targets. We already seen in the UK that the government has approved it. What about Asia? What kind of market response are you having for your technology? What is the interest like here?
Well, I will answer otherwise. I would say Europe is here really by far the front runner. Yeah. So almost all requests that you get at high TRL, technology readiness level, are coming mostly from Europe. Because that's where we had really regulation coming soon. 2030 is tomorrow. So they will have to implement this type of solution. For Asia, it's coming, but
IOM is coming. So with this event as well, so with all the knowledge that be coming as well from Europe, so and later the quantity getting bigger, so if our solution will be suitable, so it will be there.
And we did hear from Dr. Amy Kaur that Singapore wants to have 70% recycling rate for plastics by 2030, I think she said. So the market is ready. And, in Europe, you'll be, depending on the material, it could be up to 90. So it's not that different.
And the technologies are also ready. So we have the technologies there now. Now it's about taking the risk of investment and going the next step ahead.
Fantastic. Thank you very much. Please join me in thanking our speakers.
Thank you very much, you. Yeah, thank you.
I'll give 1 minute of break and then we'll move to the next presentation.